got it.
All right, so LIGO workshop, as we all know, it is, just give me a second, please.
Oh, I can summarize if you want.
No, I have the summary. Yeah, thank you so much. Yeah, so it is the ideal workshop for smart contract developers at any level who want to improve their Web3 development skills. Implementing and developing projects is the greatest approach to learn any programming language, and you will be learning LIGO from scratch with the core LIGO Lang team and build hands-on projects like games and NFT marketplaces. And as I mentioned, today we have Mr. Didier Plaindoux joining with us, who is in a PhD in covering compilation and logical programming. He joined Fujitsu as a research engineer first, later on as an R&D team leader. He worked during this period on a grid computing system. In 2014, he decided to resign and have his own activities as a freelance, working on security, mobile scientific applications, and peer-to-peer solution. In 2021, he decided to join LIGO Lang as a part-time manager and still works in parallel as a freelancer. So welcome once again, Didier, to the workshop. Thank you so much for doing this again. And we're going to let people join in as they can. And today we are going to be covering a simple Shifumi game, creating a simple blockchain-based game, understanding blockchain transparency, chess, and transaction. And Didier, I'll pass the stage to you.
Thank you for the introduction. So first, I'm going just to open the chat, just to be sure. Yeah, the chat is here. So in the chat, I post the endpoint for the GitHub project. So once again, you can. Why I cannot? Ah, sorry, I have some troubles with this window. Okay, perfect. So yes, I post the GitHub endpoint, which is named JS-LIGO Train Diab Shifumi. So once again, if you can start your Git pod or you can initiate the project right now, it should be better because sometimes it takes time. So this is what I'm going to do. Did you see my screen with the open Git pod and so on? I guess yes. Okay, I'm going to increase the size. Okay, perfect. Thank you. In order to open the projects, once again, you have to click on Open in Gitpod if you want to do it seamlessly. So I already do it this morning. So I'm going just to close this window. Is useless today. So it will take time. So during the initiation, I'm going just to do a short presentation. First, in order to finish the introduction of LIGO and just to give you a short introduction and short overview of how the compiler works and what a smart contract is. So I guess you already see this, see what a smart contract is during the day 2 and day 3. But here we are going deeper and see how to build a smart contract with a secure layer thanks to test frameworks and so on. So we are going really to play with the tests and to see how tests can help us in the design. So we already do it during the day 1 when we discover the language. Right now, we are going to use it as a basis, a base in order to have and improve and to have a secure smart contract. So first, let me do first the short presentation. Okay, so where do you see this the LIGO Foundation? So just to recap. So I mentioned that we have 4 syntaxes, which is a Camel LIGO, Pascal LIGO, Reason LIGO, JS LIGO. So I already mentioned that Reason LIGO should be deprecated soon. So there's we don't know exactly when, but soon. I already mentioned that we have some kind of interoperability because you can in GSLIGO you can import Camel LIGO code and call function and so on. You can reuse also the namespace. On Camel LIGO we call it modules, not namespace. So we have different words, but for the same the same mechanism. In GSLIGO we have namespace and so on, but behind the scene this is a module. And how the compiler works and how this interoperability can be done. In fact, at the first layer, we call what we call the front end, which has the capability to parse and understand the syntaxes, the different syntaxes. We have different parsers. We have 4 parsers, and each parser is dedicated to one syntax. And these parsers, in fact, parse the language, understand the structure, the construction, and the types, and translate it in what we call intermediate representation. So as you can see, each syntax is translated and is represented in the same intermediate representation. So this is why the interoperability works, because each file is parsed and represented in the same with the same abstract layer, what we call AST. Or CST, it depends on the layer, but here I'm going to talk about AST, which is abstract syntax tree. Then after, during the day 1, we see that we have to write types. We have to specify the types, and this is used mainly used by the type checker. So we have a type checking stage, which take an intermediate representation. This is really high level, the coarse grain overview, because we have different layer, but I just mentioned the most important one. So the type checker, which type check, of course, the intermediate representation. So then after here, if you use integer when you are waiting for strings, so as you can see, the code is rejected during the compilation. So this is the responsibility of the type checker. Once type checking has been done, we have what we call the typed intermediate representation. And one important stage is the compilation itself, compilation to Michelson. So in fact, the source code, which has been abstract and type checked, is compiled by a given layer, a dedicated layer, and as a result, it produces a Michelson source code. So the type checker, why a type checker? Type checker has been designed for what we call soundness, just to be sure that we manipulate data when it's required. So when I'm writing strings, I have strings. When I'm waiting for a function with which takes a string and return an integer, I have a function which takes a string and return an integer, and so on and so on. So this is really important for what we call the soundness. Sorry. And the one target of the compilation to Michelson is the performance. The compiler is able to have some quite aggressive heuristics, so like inlining, code optimization, removing dead code. So each dead code is removed automatically. You don't have to care. He tries some heuristic. He applies some heuristic on the code in order to optimize the code. And this is important in order to improve and to have the best performance as possible. And for smart contract, performance is really important because performance means less gas. And as you know, once you start a contract, once you execute some task in the contract, you have to pay for. So if we can guarantee that you pay less gas as possible, it's a one target which is the mandatory in order to be attractive. The first layers are written in OCaml. As you know, mainly Tezos is written thanks to OCaml, and except some library which has been designed in F-star, but translated to OCaml. And the backend is written. The backend, what we call backend, is a compilation to Michelson, is written in Coq in order to have properties and some lemma and theorems. And for instance, all the compilation and the optimization are proven. So we are sure that there are no regression thanks to the code, which is statically type checked. And Coq, what do Coq and let us do is to provide theorems, and the compiler and the compiler have to fulfill the theorem. So we prove that theorem are still correct with the code which has been written. So this is really important. So performance are proven. Okay, this is really important. So we have this is really fast recap. We see during the first day we have native types like integer, natural, Tez, string, bytes, and so on. So we have a presentation like one, hello, and so on. We have tuples, or so here we have a triplet with an integer at the end, index 0, string index 1, Tez index 2. So this is the type. And at the right side, we have the expression with 1, hello, and 42 as Tez. So just to remind you the syntax. We see we also some records. So here I define a record with a name. So the dot just means that I don't express the other attributes. This is not a syntax element of the language. And we have records. So we have values which are related and linked to k. So you just have to use k in order to retrieve the value in a given record. The order is not important, which is not the case in the tuple, as we see during the first day. And what we call the variant, which is a type with different values, with what we call constructor. So we have a variant with a constructor which is foo, and is waiting for nothing, and another one which is bar with added value which is a natural. Okay, so we can construct, and this slide is stupid because we don't write this like this, but we write with a bar parentheses. Let me correct it, sorry. So I'm going just to fix it because this is stupid. So something like this. This is better, sorry. Then after, we can, of course, write some type examples. We have a type which a by, which is a record with two Ks, profile initial controllers. We have a type which is an update, which is also a record. And finally, we can create a variant type, which could be a by or update. And by contains the value of type by, and update contains a value of update, which has been described just before. So we don't see it, but we are not going to play with the constant and variables. We have two keywords. Mainly we have const for constant and let for variables. So constant, as usual, cannot be bonified, and the variables can be set up during the computation. And in GS-LIGO, the variables are a simple one and can be designed in given block. And cannot be specified in types. So you can specify types like records, variants, and so on with mutable variables. This is really important. And this let us have some properties on the code, which is once you call a function with a value, you're going to have always the same results. Always the same result. This is what we call the referential transparency. So we have the pattern matching, what we call the case matching in GS-LIGO. This is not a true pattern matching; it's just a simple one. So we see that we have a match operation. We take parameter, which could be a variant, which should be a variant, and then after we have a record with case which repeats the name of the constructor, and we have a function which gives the behavior we want to execute once the variant has been matched. So here we have two entries, by and update, and just you should remind that the match should be exhaustive. You cannot omit, for example, the update one. The compiler refuses to compile because if you just provide the match with a by, we have what we call a partial function, and partial function are prohibited because if you call such code with update, it could crash. So it's prohibited. You should provide exhaustive match, and this is the case in all syntaxes. It's not only on GS-LIGO, on all syntaxes. What we should have also what we call terminal recursion. So if you define a recursive function, each function should be what we call terminal. Terminal means the upper call here should be the function itself. You cannot enclose the upper call in another function. So it's just in order to prevent Stack Overflow and so on. But this is quite technical, and we are not going to see it today. But you have to remind that function should be terminal. So in just LIGO, you can use another approach, which is the iteration. So therefore, you just express thanks to, for example, the imperative style and the let declaration. You can write function without exploiting without using the recursion. You can have to use what we call the loop approach, which is imperative style, and which is much more simpler to understand, mostly. We can define namespace, so you can define it explicitly with the keyword namespace, but you also define namespace implicitly once you create a file, and when you import a file, another one, you have to attach the imported file to a given namespace. So this is the file is implicitly a namespace, and you have to give an incarnation thanks to the import. For example, here you do an import of a file which is euro for the GS LIGO, and you provide an incarnation namespace which is called euro thanks to the import operation. So therefore, you can retrieve the type with, for example, euro.t, which is the type which has been provided for euro.js LIGO, for example, and we link it to a new type which is storage. So we define the type aliases here. We define here type return. So we have a return with an underscore because in just LIGO return is a keyword, so you cannot use it directly. And then after, we can create a main file with text parameters. Or this is the function. This is the syntax which has been used, which uses the kind of deconstruction. But we can also write it with action.unit, store.storage, etc. This is two syntaxes. And the import is the support for what we call the syntaxes interoperability. What a contract is. So we see the language, how to express some properties, some behavior, and so on, properties or types. So the contract has a given anatomy in JS LIGO, but the same on Cabel LIGO and so on. So first, we have to define the storage. Storage is the data which is linked to the contract during its lifetime, and the storage is going to be modified. Updated. So we're going to see that the updates it's not really an update. We have a history. So the storage is updated, but it's the same as Git. For example, you have its version. So behind the scene, you have a storage. So you have to define first the type of your storage. Here, we have defined with a simple one, which is an integer. You have to define parameter. Parameter are commands you are going to send to the contracts. So it's a variant type. It could be just a simple one. It's just if you have only one behavior. Here we define the parameter, which is it can be increment with an integer, decrement with an integer, or reset. You have as a result, what we call some operations. Operations are transactions. So if you want to interact and to perform some transaction, you have to give it as a result once the contract has been executed, and you send back the storage or a new storage. And then after, you just have to write your behavior, the contract. And here, this is a simple one with a main action. So you have to define function which is called main, or you have to specify the name if it's, you have to give the compiler the name of the main action if you don't call it main. But here we are going to call it main. And here we're producing, as you can see, a tuple for a pair exactly, with first a list which is empty. Oops, sorry. list which is empty, and we have a match action. We match an action, and then after we have to give the semantic for an action which is for the increments. So in the increments we have n, which is an integer, and we decide to implement the storage here, the store, and we return the store incremented by n. We decrement the store once once we match the decrement operation, and we reset the store to 0 once we match the reset parameter. So, and if we look back to the figure on the right corner, parameter and the storage are the inputs. So we have the storage as the input and the parameter to be executed, to be interpreted, to be used to activate the right section, the right behavior. And as a result, we produce a new storage and operation. And then after the VM, when the VM executes Michelson code, it calls the behavior with the storage and parameters, and as a result, retrieve the storage and store the storage on the blockchain on a given node. Okay, so this is how the storage is updated, and it's done behind the scene by the system, by the blockchain itself, not the contract. Contract propose the modification and how the storage should be updated, but it don't act directly with the system. This is done by the VM. We see also that we have a nice test framework. So the testing framework is really powerful. Why it's so powerful? Because tests are written in LIGO first. So you have the same level for the expression. So you're able to act directly with the source code and use the stem structures, the same types and so on. So you can interact quite easily with your contract once you write tests. And you work directly with the LIGO code, of course. So it's quite homogeneous. You have extra types and operation for manipulating Tezos context. So we're going to see it later. We have also different approach for the test. You cannot do what we call unit tests, integration tests, but you also have some mutation testing primitives. So you can decide to ask during the test to do some modification behind the scene. For example, you manipulate integer, and the mutation testing are going to mute the integer in order to see if the contract and the behavior changes, and see if you have some tests which are going to turn to red and so on, and see that if the tests are not going to turn to red, maybe you have some tests which are missing. The capability also to have generation of random values or types. And this is the first step for the property-based testing, which should be done later. We are going to provide it, I don't know when exactly, but we are going to provide it soon. And finally, you have the ability to catch error in transaction. So once you execute a contract, you can specify, and I mentioned you during the first day, if you have some property which are not verified, you should abort immediately in order to consume less gas as possible, and also to mention to the VM that the transaction cannot be done correctly, in order to stop it and abort the computation. And once you do the test, you can see if you abort correctly on given predicates and given properties and so on. So you have the capability to test it also into the framework. But this should be done only when you do end-to-end tests. When we're going to explain what's end-to-end tests. So you can write unit tests, but you can also what we call end-to-end test. What's an end-to-end test is? End-to-end test is the capability to first originate a contract. So if you remind, we can have a contract.js LIGO with a main action, and we link it to the contract namespace. Then after we can create an initial storage. So here we are just implementing one test for the previous one with the increment, decrement, and reset contract, if you remember. So with the test namespace, we can access a function which is called originate. Originate takes a contract.main. So it's the main entry of your contract, so which is a function. You can specify the initial storage, and you can also specify the amount of the wallet and the balance, which is linked to the contract. So here we set up the balance to 0. Then after, what you can do is to retrieve. So once you do the origination, you have what we call an address, and thanks to the address and the function which is called to contract, you can retrieve the contract. Just calling the function test.contract with the address as a parameter, and then you have the contract. Once you have the contract, you can do some transfer, and here, for example, you can ask the function which is transfer to contract or exception. You give the contract as a first parameter, the action you want to execute, which is increment by 1, and you can say, I'll give you 1 Mutate. So I can pay for this. I can say, okay, I give you and hide 1 Mutate to the balance of the contract. So I would like to pay for this. We pay for this, but you also to pay for the gas. Okay, so you're just wait to pay. And here you do a transaction, which is 1 Mutate once you do an increment by 1. The underscore exception stay for the once the construct can be executed, it throws it don't catch the exception here. I don't know if you have the exception as a result, or we are going to see it later. And then after, we can retrieve the storage thanks to the address and test and see if the storage has been correctly incremented. So as you can see, in 5 lines of code, you create initial storage, you originate your contract, you retrieve a contract, you execute, and you do a transfer. So you execute a parameter, so a contract, so do a transaction, and you test, and you are able to state the storage. And this is done thanks to a kind of emulation of the VM and the interpreter of the Michelson machine. So here you have a full code which is executed on an interpreted code at the Michelson level. This is really important. And as you can see, this is really expressive. We have only 5 lines of code, and we are able to express all the mechanism you see during the day 3 and the day 2, which is the origination, the call, and so on. Here we do it just with the testing framework quite simply. So this is the end of this. This is this presentation. So right now we are going to go back to our Git pod. So I guess the Git pod has been correctly initiated. So I don't know if everybody is ready with the Git pod and is ready to act and perform and to write code right now. So I'm just going to go back to the first GitHub page because we have some nice feature in GitHub. So just to be sure, and we're going to see the V1. So I'm just to increase the size, I guess, yes. So we are going first to do the first version, which is called V1, which is a basic approach. So we are going to propose an implementation with only 2 players. Okay, no more, no less, because the complexity of 3 or 4 players is not really, how to say, relevant. So we just are going to reduce the game with 2 players. So this player is going to play Shifumi, which is a player which is again you have to choose between stone, paper, and scissors. And we have and we know that, for example, if you want, you play stone and the other one play paper, the paper wins, and so on and so on. Okay, this is really a simple one. So this is. So you see with Benjamin that when we design a contract, we have to keep in mind also what we call a functional diagram, what we call sequence diagram. Sequence diagram gives you the semantics and the way you have to interact with the contract, and what is the nominal case and what are the prohibited one, with prohibited cases. So here, first one. The nominal turn is, for example, player 1 is going to choose an action between stone, paper, and scissors, and send the action. So here we have no secrets to send, and send the action and perform this action. So he send stone, paper, size 2, the smart contract, which is on the middle. Player do the same, and one player or sender, we don't care, can say I would like to conclude the game right now, okay? And the conclusion states for who wins the game, and we start a new one, okay? The smart contracts are going to be designed for only 2 players and always the same ones. So if you want to initiate a new Shifumi game with 2 different players, we are going to originate a new smart contract, okay? Prohibited sequences are this one. If player 1 would like to act twice, he cannot. So once he understands the action, if he wants another one, so if you want to change it, he cannot, okay? Once you choose it, the action has been stored and cannot modify. So this one is prohibited. You have another one. The action, of course, cannot be modified once the player plays, okay? We are going to see what's important. Of course, we cannot conclude if no player plays, or even if one player play and not the other one, okay? So the sender can conclude only when players are only when player 1 and player 2 are played, okay? The conclusion cannot be known when the game is partially done, and that's all. So how we are going to do it? So thanks to the day 1, you have a first version. You have 3 versions. The first one, which is V1, and on V1 you have what we call a makefile. So here I'm going just to increase the size, I guess. Yeah, I think this one is a good one. So you have the solution, and you have the library. So here we are just going to in V1 directory and do a make. Okay, so I'm going just to initiate my my LIGO version thanks to Docker, and going back to the documentation. So we have different files. We have so I split the contracts in 5 files. The first one, which is the action, you have 6 one, but the one which are not going to, we are not going to design it because it's a simple one. You have the main file are actions. Actions are going to be stone, paper, and scissor, and all the operation related to this type. What we are going to design around value, around storage, and the main. So we're going just to see the relationship between each data type. We have the action, and the round value is going to refer the action. So the round value is the action which has been played during a round. You have a round which is the values which has been played by each player. Okay, so round refer, round value, and the player. So we are going to see it smoothly. Don't be scared. And finally, we have a storage which reuses and refers round player. And at the end, we have the main contract, which uses storage. So we are going to design step by step each modules or each files, because I was explaining a files is a module, and we are going to design step by step in order to see if we are quite fluent in GS-LIGO, and just to improve also our skills in writing code, and also in our conception of the contracts. So go back to the, I'm going back to the contract. So I'm just to open the action, and here I already saw static library and download static Linux LIGO. So it's been done. Okay, thanks. And here I provide you the types. Already provide you the types because of once I do it for the Tezos Israel, I don't provide the types, and it takes too much time. So here I provide the types, and I give you some constant like stone, paper, and scissor where I'm going to use it. So the first operation we're going to implement are just simple predicates, which is I'm going to implement a predicate which states if the value t, which is parameters, is a stone or not. So the predicate checking is the action is a stone. We're going to provide a second predicate, which we are going to check if the action is paper, of course. And we're also going to provide a third predicate, which states if the parameter is a sizer or not. And I give you also a predicate, which says if the winner with the parameters, the first parameter is the winner, and the second one is a loser. So for example, if the winner plays sizer and the second one play paper, the winner is the first one. So the predicate is true, and so on and so on. Okay. In parallel, we have given some tests. So just to explain you tests, here we have some simple one. This is what are called unit tests. So we are going just to call to check some assertions. So we're going to is paper with action paper is true. So it should be true. Of course, if is paper stone should be false, and so on and so on. So I designed just stupid but really really basic operation. And at the end, we have cases with case 1, 2, 3, 4, and 9. We're going to be executed in order to see if each test is verified or not. We have the same for the round value and so on. And at the end, we have the most important tests, which are the Shifumi tests, which are the integration tests already mentioned during the presentation. So here we're going to just to check once, for example, if Alice, if for example, I'm going to just to explain this contract. So we are going to get the contract. So here the contract is just origination and the test contract. So the both function has been grouped in another one, which is a local one. You see get contract. So here you have the origination and the get contract. So if you remind, if you need the contract, you first do the origination. You have the address as a return value, and then you have to use it with the two contract in order to retrieve the contract. So here I do it in one function. I create 3 players, which is Alice, Bob, and James, thanks to the values with a function which is reset state. So here we have global aspects. You cannot do it locally. So it's a kind of what we call singleton. So global context, global values. So then here we create initial storage with Alice and Bob, with the address of Alice and Bob. We get a contract. We set up the source to say, oh, the sender which is going to act and to perform transaction is going to be Alice. Then after we transfer the contract, so and the transfer contract is done and executed with Alice as a sender, and we decide to play, for example, action paper, we send 0 test, and then after the transfer to contract don't raise the exception, so we are going to see if the contract is going to be run correctly or if it send an exception. So here just going to assert and see if the execution is a success or not. And here we can see, for example, the assert, and the assert of success is going to pattern match something which is a failure and a success. Okay. So here in this file, which is called T5 Shifumi, we explain all the operation. For example, here we check that Alice cannot conclude. So for example, Alice decide to conclude, and this in fact covers this case. Okay, I decide that if the sender is Alice, for example. So here I decide that Alice would like to conclude, but the game has not been played right now. And here we should have a string failure, which is cannot conclude. Okay, the cannot conclude has been designed in the error file, which is here. The cannot conclude is it's just a string, and we are going to see how to raise this error. So as you can see in this Shifumi file, the test are what we call the functional test, or the high-level test. And here you can define and write the test for each sequence which has been designed here. So you can write the test for each sequence on your file, and you can read it quite easily, because you see that you create a contract, we perform a conclude, and here we cannot conclude. So yeah, you can have really expressive test expressed thanks to the test layer and the capability to retrieve error, the errors or the success once you execute your storage. Okay, so after this long explanation, we are going to write our first predicates. So if everybody is ready, we are going to start right now. So we are going to build step by step and see how to build the contract. So we are going to have a bottom-up approach. So we are going to write the functions related to the basic types like action. Then after we are going to do the same one for run values, and then after for run for the storage. And at the end, we are going to design the main action and the whole contract, and we're going to test it. So if you remember, we are going to first do oh, sorry, where's my terminal? Here. So here explain that the predicate checking if the action is paper should be implemented, which is this one, paper, is paper. So I think this is this one. So I can just to revert this one. So we are going to just implement this one. So I execute it. So just to have the right order. I'm sorry, the order is not the good one. So we are going to solve this one, this fail with. Or fail with, we don't see it, but fail with is the how to raise an exception in JS LIGO. This is the real native function, and then this function is a polymorphic one. So once you call fail with, the result is the one you are waiting for, which is bool, because it's a polymorphic function. So what we are going to do is choose to implement, removing the fail with here, and we're going to implement the predicates, which states that A, which is of type T is the type which is declared here. We are going to see if A, the action, we can call it action if you want, if you need expressive parameter type, if the action is paper and only paper. So I let you work on just this on the first predicate during 3-4 minutes if you want. And just to remind you, if you just don't see how to write this code, I just give you just a short recap in the documentation with the language basis, and of course with the variant and how to do the pattern matching with the variants, which is explained here. So here you have the syntax and the way to do the pattern matching. So I give you 4 minutes to do the first one, and after the second and the third one should be done quite quickly. So that's fine for me. So I give you 4 or 5 minutes. If you have some technical question related to this exercise, do not hesitate. And I'm pretty sure that you have global function. This function should be posted later at the end. Thank you. So once you finish the exercise, do not hesitate to mention it on the chat, just to let me know if you are able to read it quite quickly or not, and so on. And just one important remark, today we are not going to play with the web app. We are just going to design a contract from scratch with a bottom-up approach, and to see for some facilities and some capabilities which are offered by Tezos, the Tezos framework, especially for the gaming. Okay, 1 minute left. So are you able to write the code? Okay, perfect. So I'm just going to write the first one, and we are going to see that the second and third one are the same one, except. So we are going to use, because the type T is a variant, of course, so we can action could be a stone or a paper or a scissor. So you have to deal with all the different values. So I would like to perform the action. So I would like to match. So we can write return here or not, because the last operation is pushed on the stack. So this is why the return is not really mandatory. So first one, a stone. If it's a stone with no value, I'm waiting for a paper. So if it's stone, it's false. So it's not a paper. Then after we have the second one, which is a paper. Of course, the predicate should act that it's a paper, so if it's true. And the last one, which is scissor, and you remember that we how to say, express all the cases. We don't have, for example, a default cases. We're explaining if it's paper true and otherwise it's false. You have to explain in just LIGO. You have to express all the cases every time. False. So right now we can execute the first tests. So as you can see, we have 3 tests which has been done, which is true, false, false. So just to be sure that, as you can see, we're expecting for true, okay, and testing, and we receive false. We don't have the line number. I already mentioned it, but we don't have the line number. It should be, it could be really nice if we get the line number. So here we are the first step. The first test which has been done. So the next one, which is 919, we have to set up this one. So I give you this is quite simple. So I give you 1 minute for each one, and then after we can go to the run. It's really simple one. So here, one important thing which has been done here for the design, this is software design. This is not related to the contract, but this is the way I do the code main time. I do most of the time. Sorry, this is how I do the code. Here I define the type T. We know that the type T is visible once because I do an export here. Okay, you have to export the type T because you have to use it. So once you export the type T, you export also the constructor. But here I use some constant in order to hide the constructor is, and here I have some predicate in order also to hide the name of the constructor. And I do this because if I want to translate it, for example, in French, I can write Pierre and change Pierre in this file without requiring any modification in other files. Okay, just to prevent that the modification could be local, and then after paper should be just done calling Pierre in French, and that's fine. You're just in the outside layer, in the outside, you're using Pierre, paper, and inside the constructor is Pierre. So you protect your code, and if you want to modify it, you don't have to do some refactoring, to deep refactoring and so on. This is one approach. You can be agree or not with this, but this is the approach I mainly use once I do some when I design the code. And of course, for the contract, I do the same, just to prevent some what we call some kind of adherence. I don't know if the right word in English. You have some aspects which are externalized, and just to reduce the risk once you do the design, you just have to protect your code. Things are adapters and constructors and predicates and so on. So therefore, you are able to protect the definition of the type. So for example, you have this kind of operation. Once you design, for example, in OCaml, if you don't know if you already write code in OCaml, but you have what we call modules, and in modules you can define abstract types. So the type is not defined; it's just explain. You explain the type exists, and you can in the implementation provide an incarnation of the type, but this incarnation is absolutely hidden. You cannot use it in an external code in the other modules. It's protected. So I do this even if the protection is not verified by the compiler. It's just a protection done by the code. So back to our. I'm going to just do a copy paste. I know this is not a good practice. Just to have to do it quite quickly. So we are going to stone. So once we have a stone, it's okay. So we can do some execution. Stone not found. Stone not found. Why stone not found? What is the? Oops. Which 9? 6. Ah, of course. Pierre. I have to rename it Stone because I renamed it. Yeah, so Stone. Sorry. So here and line 19. So action. Ah, yeah. I call it action, but here you have to call it action, of course. Otherwise, the name of the parameter is not a good one. So here we have six tests which are successful. And of course, for the sizor, we can do the same action. And we have here a first set of predicates which can be designed and let you decide when an action is a sizor, stone or paper, and you are capable to see who is able to win the game and not once you call this function with two actions. So this is really simple, nothing else to say about the actions. Okay, so once we design the action, we are going to design what a round is. So round value, a player has different states. We're waiting for a player to play, and we also another state which is a play as played. Okay, so it's a kind of really basic automata. So here we define once again a new variant type, which state and give the status for a given player, the status of for the game of what is going to do and what should be done for for one player. So, for example, at the beginning of the first states of a player, once we start a new game, is we are waiting for the player to play, and then after the player can play. Okay, so here we are going to provide once again, as for action, we are going to provide a first type which is waiting or played with the action which has been defined just before and which has been imported here. And we are going just to create a first how to say, smart constructor, which first a constant, which is waiting, and which called the constructor waiting. So this is the initial value once we are going to perform the range value. And once again, we are going to first perform and write predicates. The first one, predicates, which check if the run value is waiting, and the second one is checking if the run value is played. Okay, and then after we are going to implement a played action. But first we are going to design the predicate. So I give you 3-4 minutes for this one, and then after I'm going to explain you the play action, what is expected once you do the play action. At 10 o'clock. Okay, if we remind the action, the code should be done quite quickly. It could be done quite easily. So we're going to implement the first one, which is waiting. So here we see that we're going to use step by step the data type we're defining. Okay, so here we are using the data type which has been provided by the action .js.LIGO file, thanks to the namespace action. So here we're going just to do a match again, return, so match round value. And here we're going just to specify the different entries. The first one, which is waiting. Waiting has no associated value, so waiting. So we are writing a predicate which which checks the run value to be awaiting, so it's true. Otherwise, it's a played value with a parameter p. So I have to underscore after and add underscore, I guess, because otherwise we maybe have a warning, but I write it like this. It's okay. So here, yeah, the trust is here. So the expected value is true. Okay. So there it does not mention you have a warning. So I guess if you compile the code, but it's test, so this is not important. The same for the played is played. So here, what we're going to do is I'm going just to check if my run value is played or not. So here, this is false, and this is true. So for the moment, the code which has been written is quite simple, but it explains and it uses mainly match function and variant type. So since it's not the simplest data type, it's not useless. So here we have the expected false. Well, this is curious. Expected false. Why? I don't see. Well, we can go through the test. Case 2, case 3, case 4. Okay, so as you can see, I don't write the test for the plate, so I'm going just to write new tests. So I'm going to call it 3, 4, 5, and 6. I'm just going to add a new test. So I'm not covering all the cases. So I'm just, and this is not how to say normal. So I'm just to increase the number of tests. So here we have a test which is waiting for waiting. So what is missing is, did we have a test for? Yes. Yes, this one should be 3, the third one, and this should be the second one. Right. Here we're going to test all the cases for is waiting. So here, no, I cannot because I'm not able to write sorry, I'm not able to create the played. Okay, so I don't do it. I just would. I just remove these cases is useless. Sorry, my bad. Okay, and here you have to remove this one also, I guess. Yeah, and finally this one. Sorry, this is a weakness in the design because if you remember, we are not able to create a played action. So if I create if I write the test as I mentioned, it's not covered at 100%. So it could be improved. To be honestly, it could be improved. So back to the run value. Sorry for this. I just check the test. Okay, so here we are going to write this behavior. So it should be much more complex. So what is expected is we should provide a play action for a given run value and action. So what I'm waiting for here, the run value is the current run value. It represents the states of a player, okay? And the action is the action I would like to play. So in this function, once you call play with a run value, which is waiting for action, I would like to have a played with action as a result. And if the state of the run value is already played, I should do nothing. When I say I should do nothing, I should return the same run value. Okay, so just to mimic, if you remember, once we play, if we play once, we cannot modify the value of the played value. So here, play should mimic this. Then, if you are waiting, you can play, and if you already played, you cannot play. Okay, but we don't send an exception here. We just say, okay, it's just in identity. Once you played and you want to play once again, I refuse it. I don't perform the action. I stay with the action which has been done before. Okay. So I let you write this code with during 5 minutes, for 5 minutes. And if you have some question, do not hesitate. I hope it's clear. I can express here if I'm waiting plus action, I would like to have a played with action. And if I'm played with action plus action prime, I would have as a result played with the action. Okay, action prime, which is this one, is not used. I'm going to call it action prime here, action this one. Wait, I should say with played action prime. This is what is expected. Waiting, I can play. Played, I cannot play. One important thing I don't mention here, we need the export keywords in order to manage the visibility. If you don't add the export here, you cannot use the play action outside. It's a private one, so it's private to the package. Same for the type, of course. Same for the type. So saying this, the code should be quite easy. It should be quite easy to write, in fact. Okay, and here we can see that's really it's a kind of automata, because here we have the state, the transition, what we recognize, and the new state. So 1 minute. So here this function can be written thanks to the match once again operation. So here we are not going to match the action because the action is not important, but we are going to match the run value, which is the state, the current state, which is the most important parameter. So we're going to match the run value, and this run value can be awaiting. Or a played. With my action, which is A. Okay, so I say once I retrieve a waiting, once I'm a waiting state and I receive an action, okay, I can say, okay, I'm in the play state with the action. This is what expressed here. We express in the comment here. Otherwise, if it's a played, we know that we cannot play twice, so we just return a played with the action A, which is the action A, which is the old one. Here it's the old one. Okay. Then after we can make a test. So the run 2 is finished. So I don't know if we can execute. No, everything is executed directly. Okay. So here the run values has been finished. So if you remember, sorry, we design an action which is able to give us a predicate to test once we play stone, paper, and scissors. Here we play a run value which reflects the state of a given player. If a player is waiting, if we are waiting for the player to play, or if the player has already played. Okay, so this is the status of the player. Then after, this is what we call a round value. Then after, the first step is to define a round. This is a test, of course. And the round, as you remember, we say that the round concern only 2 players. Okay, player 1 and player 2. For this purpose, I define a simple test which is called player, which is player 1 and player 2. It's just a constructor to reflect which player is playing right now. So we're going to see later how we're going to map this player with the external values. So here the round, in fact, should reflect the current state of a game, of a turn, okay? So for this purpose, I decide to use a pair, but we can use also a record, which is the first one, which is a run value, a pair with a run value at the index 0 and run value at index 1. So I state that the index 0 is a player 1, index 1 is player 2. We know that in computer science we start by 0, never by 1. Sorry for this. And I create a fresh round, which is a new game, a fresh round, which is I'm waiting and I'm waiting. So first player is waiting and second player is waiting. We are waiting for both players to play. Okay. So then after, we we have to create first function, which is a kind of function projection function, sorry, which say for a given round, which is a pair, I would like to retrieve the round value for the given player. So this is implementation we have to decide. And here I would like to say index player one, it's the index 0, and player 2 is the index 1. Okay. So we have just to write what we call projection function for the deconstruction, thanks to the value player 1 and player 2. So I'll let you write this function during, I guess, 3 minutes. It's not complex at all, but it just remind you how to retrieve information for a tuple, and mainly here from a pair, just using index and so on. So we already see it during the first day. This is just a recap. So once again, if you don't remind how to do it, you can open the documentation, which is, I guess, not this one, but this one. Not this one, sorry. Tuple, this one. So if you don't remind, do not hesitate to open the documentation and read the documentation. You have to retrieve the right syntax, which lets you extract information from a tuple. So I'll let you work during 3 minutes right now. Time is it? Okay, nice. So here, one important thing is you are not going to protect player 1 and player 2, and I'm going to explain you why later. I already give you some explanation during the first day, but it's important to give you the explanation once again related to the player 1 and player 2. So as you can see, protecting data and protecting data types, it's not so easy. It's not a task which is so easy. Sometimes we cannot, or we should design differently. And this implementation we cannot, so we have to go through player 1 and player 2 and recognize each one. Okay, 1 minute. Something which is missing also this one. Cover test. It's not complete. Just would like to check something in the round value on the tests. So inside the test coverage, I go back to the run value. The test coverage is complete because I use the play and the is play on the test. So if you remind, the first one, which is rating, I check if his waiting is really waiting. His waiting is played. No, this is okay. It tests this one. Tests the waiting stage. The play stage is done thanks to the play action. So once we have a waiting and sizer, we're going to check that it has been played, and is played. So here we can check also if it's not a waiting, of course. So here we have to check. We can add another one, which is if it's a waiting, and once we play, it should be false, of course. So this one is missing, and no, it's okay. It's here. It's here. And once you do a play with a waiting, check its waiting, it's false. So here you check all the capabilities and possibilities with the predicates thanks to the play action. Sorry, this is just because I'm not convinced at the beginning by the code that I wrote. Okay, so this one could be done quite easily. So if you remember, we are going to check something, which is here the most important part is not the round value, because we have the round, but we would like to extract. If you remind me, if you remind the play action here, we would like to have the round value, so we have to breed a new one. Okay, here what we want to do is just to extract new information thanks to the player. So here, how to do it? Just simply do it matching the match case over the player. So we return match. So I'm going just to match player with player one with no parameter, and player two. And we are going to see how to extract information. So I stated just before that if player one is the index 0, if player two, it's the index 1. So I just return round. The information which is in the index 0 and the top round, and the same here at the index 1. And that's all. And you have to put the comma here. Okay. Okay. And we can do, so we can make, okay, and say that, and we have to implement this one right now. So if you remind, I said that we can write the code differently. And I just would like to recap this, which is really important. If you remind, we can write this code also using ifs and else. Okay. So here, for example, you can state if player player one. So here I'm using the smart constructor, or you can use directly player one. This is not a big issue. I can return round at the index 0. Perfect. And otherwise, I can state, as you have two different approach, you can say, okay, I would like to have round 1. Okay. Well, this should be okay, of course. Okay. So here we have to implement line 20. So it means that this one is okay. This test is okay. Okay. Just to show you that the test is okay, I change it, and we should have a failure. Of course, we have no failure. And why? Because I'm stupid. Ah, okay. Because the round value all the round value are waiting. Sorry. Okay, I just put something which is here. Stupid test. Because I'm not able to see if the round value is the one. All the round value, once the fresh one, it's waiting. And of course, I do not play the, okay, stupid tests. So you see that designing tests is not so easy. So why this part should not be written like this? Because if I decide, for example, to say, okay, I would like to add a new player, a third one. I can decide to add a third player, player 3. And then after here, I'm going to, for example, test for the player 3. So here I decide to test for the player 3. Okay. The test is not correct because here we state here that this value should be returned for any player which is not player 1. Okay. So here we can say, okay, I can decide to add another one, which is player 2. And in initial design, when we have player 1 and player 2, we have to fail with because we have to return something which is impossible, for example. And here, if we add the player 3 later and we execute the test, we should have something which should be a contract, blah, 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 statement expected at this point at top level, and something has been not written correctly. Player, sorry, 4, of course. You have to remove this one. Blah, blah, blah. I have a syntax error in the round. Where is the syntax error? Oh gosh. Here. Yeah. And player 3 not found, of course. I'm going to just provide player 3 like this, just to show you what's going on. If you decide, in fact, later to add a new one, we have the test, which is it fails with impossible. And that means that if you decide to extend the code, you write the code with if and else with, for example, fail with, like I do, which state that this case should be impossible. And if later you add a new player without performing a test, if you don't do the test correctly, like me, for example, like with stupid test here, you should have some failure and the contract should fade once your origination has been done. So for the design, this is why I'm really very careful. I carefully say this. You should always use what we call the idiomatic construction of the language. So if you want to test a variant type, you should mainly use the match operation, not the isn't and so on. This one is not the good one. Okay, so just go back to the player 3 and remove it. No, sorry. So you must keep in mind that we should always use as much as possible the match operation once you deal with a variant type. This is really important if you want to improve and to have contracts which are really robust. Okay, because if I decide to add once again my player 3 here, and I stay with my match operation here, I can try the compilation. I can try to do compilation, and here compilation is really gentle with me because it says that, okay, you wrote the code, which is player 1, player 2. Later you add the player 3, and here this case is not exhaustive or errant or not. So instead of having some execution which fails during the test or during your contract execution, here the compilation is broken and it refuses to compile because the pattern matching is not exhaustive. So here you should have to review the code, and this is the good pattern. It's the good approach to to write code, thanks to once you have to deal with variant type. Okay, saying this, this is I think this is one important remark, really important. So here, what we're going to do right now, we're going to implement the play action. So we have the round, which is the round for the player 1 or player 2. We know who is playing, maybe the player 1 and player 2, and we know which action is going to play. So once again, I would like to use the play action, and would like to play to write the play action using the play action or the play we already defined in the round value. Okay, so this is just right now which player is going to play and what action has been selected for the to play. Sorry, I'm sorry for my English. Which action you would like to play right now? Okay, and this should be done thanks to the current round, which is the first parameter here. It's not object-oriented approach, but here the first parameter is the value we want to act on. And here, as a result, we would like to retrieve a new round, okay? So here we see that we are going just to not mutate, but provide a new round. And this is the way to do it with GIS LIGO. You have the value, and you have to provide another one, which reflects, in fact, the operation we want to do right now. So in play, we would like to perform the action for the given player on the given round, and then after we have to retrieve the final round, which is the result of the play action. So I let you write the code during 5 minutes. I let you, yeah, 5 minutes. 5 minutes, it's okay. So after we are going to build the storage, and finally we are going to write we are able to write the contract. So maybe in 20 minutes, the contract is finished. 20 or half an hour, yeah, half an hour, I guess. Then after we have 1 hour to work on different new approaches. Okay, 4 minutes. So here in this, in the code we are going to write, we should remind how to retrieve information, how to rebuild to recreate the tuple and so on and so on. Just one trick. I'm not going to use the get round value, so do not hesitate to not use get round value. Get round value has been just introduced by in order to just to review and to recap how to extract information from the tuple with the projection using indexes. This is the only. This has been only for this. So we designed the function only for this, to merge pattern matching and the round value, and also to explain the ifs and else, the trick with ifs and else, and the capability to have broken codes once you decide to have much more players. This is the only target which has been the only thing which has been targeted once we define get round value. It's not to be used, in fact. So. Okay. So we're going to write the code right now. So here, first, we are going to match something. So we have the round, we have the player, and we have an action, and we'd like the player to play the action. So we have to first find the right round and to act on the right round. So first we have to do the pattern matching on the player. So if it's a player one, what I'm going to do, I would like to recreate a fresh round, if you remember. So the round, it's a tuple, of course. If it's a player one, we know that the player two is not going to play, so we can retrieve the value of the player two, which is at the index one. And here, what we have to do is to call the round value play, okay, with the current round value attached to the player one, so which is round value 0, and the action. And here we have just syntactic correction put in order to explain the depth. Okay, this is for player one. Then after we have to do it the same for the player two. So as you can see here, I don't use the get round value because if I can do it here, but it's we do twice the pattern matching, so it's useless. So we know that player two is going to play, so round at the index 0, which did not represent the round value of the player one, should not be modified. So we pick up and return as is. Then after we have to write the round value play. So we know that this the player one which is going to play. So we are going to retrieve the round value dedicated to player one, which is the index 1, and we act on the action 1 on the action. That's all. It's finished. There's no. Okay. And player 3 not found. Oh, of course. Player 3 on the test. Yeah, this one. Sorry. Storage, initial game, value initial game not found. Yep. So, in fact, for the run, everything is finished. Okay. So right now we define what a round is, a current game, what a round value is, which is what is the state for a given player. So are we waiting for player two? Are we waiting for player or a player or did the player already played? And the last fine grained type, which is the action itself, which is the the scissor, paper, or stone. So then after, we have to design the store. So if you remember, the storage is the data, which is the information which are stored in the blockchain and which is retrieved and sent back to the contract once we would like to do a transaction. So the storage, we are going to define the storage here. So something is missing, which is the initial game. So we are going to first here, it says that a variable initial game not found. So this is normal. So we are going to implement it. So I'm going to let you, I'm going to give you the initial game. But first, we are going to go through the type T, which is the type of the storage. So storage is which round is played at the moment. Okay, so once, for example, a game has been finished and we state for a winner, we initiate a new one. So we increment the number of the game and we know how many times player play the games, okay? And this round reflects how many times we play the games. We have also a pair of addresses which reflect the address of each player, okay? So here, once again, at the index 0, this is the address of what we call the player 1. Index 1, this is what the index of the player 2. And then after, we have a construction, I don't know, we don't see this construction, which is a map, which says for a given natural, we can have a round value, a round value attached, okay? Or maybe not. For example, the map is this one, could be, we can go through here. The map is a construction which lets you store information with a hash value. So here, where we can define, for example, an address and a move. In order to create a map, we called the basic constructor, which is map.empty. You can also create a map with literals. So map literals take a list and a list of pair, okay? Accessing the map is done thanks to function like find opt, and find opt takes the value which has been used for as a hash value and gives you the results or maybe nothing, which is an option. Okay, so here we are going to see a lot of things. We are going to see the map, the optional, and so on and so on, just thanks to this construction. So first, I'm going just to give you the initial game, which is this one. So I let you read this code. So I'm going just to create the initial game. Initial game is I would like to design it thanks to two addresses, which has been given as a parameter. First one for player 1, and second one for player 2. And I create the brand new storage. In fact, this is the storage at the beginning of once we do the origination. So how many rounds has been played? 0, of course. The players are P1 and P2, which are related to the address here. And we are going to create rounds with the first one, which is at the index 0, okay, which is the current one. And we say that the current one is the fresh round, okay? So nobody plays. So here, fresh round is, if you remember, it's a pair with 2 round value, which are waiting and waiting, reflecting the status of the game for each player, for player 1 and player 2. So this is the initial game. So I let you write the code on your file. I don't know why it's missing. And then after, we are going to right now do some manipulation of the storage. So here we are going to see how to create a fresh game. It means we are going to initiate a new one. In fact, initial game is what I call fresh game here. So we can remove this this line of code. Yeah. We are going to initiate a new game. So in fact, in the source code, fresh game has been renamed initial game. Sorry. I just would like to check the code because initial game, initial game, initial game, initial game, initial game, initial game. Okay, no fresh game, no fresh game. Okay, sorry. So we are going to say how to create a new game. So I let you write this code, okay, and compile it. We are going to, thanks to an address and the storage, we are going to see which player is going to play, if it's a player 1 or player 2. And here we are going to introduce what we call optional, the option. We are going to retrieve the current round for given storage. Once again, here we are going to manipulate the map and the option. And we are going to also provide a function which is an update round. For given storage and given round, I would like to update the current rounds. Okay, so first we are going to design the new game here. So I let you, new game means we are creating a new one. So it means that the round value should be incremented and the rounds should be initiated by the new one. Okay. We don't care about the state of the round. We don't check if the round is finished or not. We don't care about this. We just provide a fresh, brand new game, just incrementing the round, and just adding a new one in rounds. Nothing else. Nothing else. Just adding. We have the guard should be put later, and this is not the responsibility of the new game to check if the game is finished or not. So just a simple function which recreates the record, propose a new record with a new storage, modifying so the round and the rounds. Okay. So this is just a recap also to see how to rebreed the records easily. So thanks to the basic construction. So once again, we can go through the documentation, which is so the records and maps, this one. So thanks to the operator, which is ... for the update. What we call the functional update. So just to remind that we cannot mutate information which are stored in the record. So we have to recreate a brand new one at each time. If you want to reflect the update, you have to create a new one. So I'll let you work during 3 minutes. Yeah. Just would like to test to see if everything is okay. Okay, 9:29. 29. To change, in fact. Initial game, get player. Okay, I have no test for this one. I have no test for the new game. Okay. So 1 minute. I'm pretty sure that this parenthesis can be removed. It's not mandatory. Yeah. Okay, so what I'm going to write what a new game here is. So it's just a creation of a new record. So we are going to provide this new record like this. So first, I would like to provide a new storage. So the first operation should be done is to say, okay, I'm dealing with the storage, the current storage. So I retrieve all the information. As if you remember, it's a shallow copy. So we do a copy at a higher level. It's not a deep copy. Then after, we would like to define the new value for the round. So what I'm going to do is just to define a constant with a new round, for example. I do it because I'm going to use it twice. I'm going to use it twice, sorry, new round. So the new round is the storage dot round. So we use the attributes and the field name to retrieve the value of the current round from the storage value plus 1, and it should be natural, so as nat. So I have to mention 1 is a nat. So since we have a new round value, we can set up the round field with the new round value. Sorry. And the rounds should be updated, adding a new one. So how we do it? We call the mat update. And we are going through the syntax and just to see how to do it. So I'm going just to go through what we call the API here, the function, the modules related, the namespace related to the map. And the map says, okay, in order to update, I have to give the key. I have to give a value which is an option of my value and my map. Why we give an option? Because if you decide to set up with none, as is mentioned here, it says that the entry should be removed in the map. Okay, the none is the capability to remove something in a map. Otherwise, you have to use a constructor which is sum. Of course, we don't see what option is, so we are going. I'm just going to explain you what option is. Option is, in fact, it's a variant type, which could be some or none. Okay. So here we have the API. So the type is not explained here. Here's option. Okay, not option. This one. Okay. Here. So we can have values which could be some or none. And of course, since it's a variant type, you can do pattern matching over the values which are provided by the option type. Okay. You can extract the value with the function unoption sum in case the value is sum with raise with an error. So we are going to deal with. Okay. So here we have to do some updates. So the map updates the new entry. So we have to, the new entry is a new round. So we are going to create an entry for the new round we are designing. We are creating a new round effectively. So we are going to add some value. What is a round when we start? It's a fresh round. And what is a map which would be modified? The storage dot map dot rounds. Okay. And that's all. So here we say we would like to update the storage, the storage here, which is map storage rounds, which is the one we are going to modify. And we update it you just adding, saying that we have a new round, which is my entry, and this new round is linked to the value, which is the round fresh round. Okay. Once again, here, round storage is not modified. It sends you a new storage. Okay, it's important. It's a new map. Okay, no maps. It's not a side effect. So if here I would like to check if the storage, the initial rounds, if the map, the entry exists, I would like the predicate should say no. Okay, so this is not a side effect. It creates a new storage. Okay. And that's all. So not what we're going to implement is, thanks to storage, I would like to have the current run. What is the current one? Is the one which is referred, which is referred thanks to the round attribute, the round field, which is here. So if I have a round one, I would like to retrieve in the map the round which is referred by the natural one. Okay, so I let you write this function. It's just a simple function, and this function, of course, return an option, because if you decide to retrieve a one which is not yet, which does not exist at the moment when you call it, you should return none or some. Okay, so here what you have to do is just to read how to do it. So you have to read this part, this section, in order to see how to use the sum and the known constructor in order to reflect the optional value once you decide to retrieve information in the map. Okay, so I'm pretty sure that you don't have to do it directly because the function do it for you transparently, but you should read this carefully in order to understand what option is and how to work with. I have to work, sorry. 4 minutes on this topic. It's just a simple call. So you just have to go through the API related to the map, and just reading documentation, you should be able to find the right entry in order to provide this competency, in order to implement, sorry, this feature, this function. Sorry. So I let you work during 3-4 minutes. Sorry. Mm-hmm. 1 minute left. Okay, so this one should be done quite easily. If you go through the documentation, you should mention that we have a function which is called find_opt, and the find_opt perform an operation which takes a key and try to find a value. And if you have no value, it returns none. If it find a value, it returns a sum with the value. So it already returns the option value, okay? So you don't have to deal with the construction of the option value. So this one should be done simply, calling return map. Then I'm going to call map with find optional find with the storage, the current round, okay, in the storage.rounds. So this is how to retrieve the current round. Simple. So we can execute the test right now. Okay, it's okay. The test expected has been the one we are waiting for. So right now, I would like you to spend a couple of minutes to write get player, but because this one is a little bit tricky, and it drives you to and it forces you to use this constructor, which are sum and none. So I let you work on this one during. It's a simple one because you have the player, which is the address. We have the storage. So if the address is the one which corresponds to the address at the index 0, you should return 1, player 1. If the address corresponds to the address at the index 1, it should be player 2. Otherwise, it should be something else. So this is why we are sending an option, and this is a one way to say I have a result or I have no result. So I let you work on this function during 4 minutes. Because you have to deal with the sum none option. Okay. And here we're going to see once again what we call a idiomatic construction once again, and a good way to say I would like to do something. I would like to return something, or otherwise, if I cannot, I return something which reflects the fact that I have no value as a result. So if you remember the function I wrote with if it's a player 1, then I do this one. If it's a player 2, I do this one. Then I could use an option saying, okay, I return nothing. In the case, no, it's not player 1 and player 2. So I have to deal with the value. So I have to manage it in the code. So it could help and enforce the security and of the contracts because you don't have to raise an exception. It could be a normal case. It could be absolutely normal case. For example, somebody can decide to play with this contract and send an action, and if this address has not been registered, it should be rejected. So, but we are not able to retrieve the player which is related to the address, which is not the good one. So this function reflects this one. Okay, 2 minutes left. So in the all languages, we use null. As you know, null is not a good pattern. In functional programming languages, we use this kind of construction, which is called option, for example, in OCaml, or mainly in Java also, even if you still have the null. In Haskell, it's a maybe, and in Kotlin, it's a question. In Kotlin and Swift, you have a specific syntax with a question mark. with some specificities, because if in Kotlin you write the type with question mark, it's the same as a type with a question mark, which is not the case in Swift. You can have the option of option, which is quite natural. So here we retrieved some idiomatic pattern. We have some most modern and functional programming languages. Even if we're dealing with JavaScript, you have it in TypeScript also. So this should not be a big issue. Okay, 1 minute. Okay, so I'm going to start to write. So here, address, we have only one construction to do it, because address is just a native value. So pattern matching cannot be done. It's not a variant type. So we have only one construction in language to be able to help us in this case, which is the ifs and else. So we have to deal with the if. First, if the address, my player, the current player, which is an address, equal is the same as the storage dot players players, I see. Okay, I have to write it by hand. At the index 0. Okay. I return. So I would like to return player 1. Okay. But the problem here, we have to deal with the fact that we can also say I have no value. So here I say, okay, I have a value which is sum of player 1. Else, and here the test should be done for every entry, because the player could be someone else which should not be maybe this player 1 or player 2. So I have to deal with. So my storage dot players, don't give me the player with the S. Why? Because it's an attribute. Okay, it's not player 1, a player at the index 1. Okay, we say this is the player 2. Once again, we deal with the value, so we have to say I give you a value. Otherwise, we say it's not a player 1, it's not a player 2. So I have no round, I have no player to return. So I say I none, return none. Okay, so here we see something important here. We have the capability to say to the system, okay, this is not an error, it is just normal case. Okay, you would like to retrieve the player from a given storage with a given address. Okay, but if this address is not the one which has been referred for the player 1 and player 2, okay, I cannot retrieve it. It's not a script, it's normal. Like the map, when you try to do some find option, or you're trying to access something in a data structure, but maybe the value does not exist. There are no corresponding value. So in order to reflect it, we send an option. Okay. And the update rounds, I'm going to write it right now, because the update rounds is just to update the current rounds, and the current round is in a map. So we are going just to modify the map, calling the update we already use here. Okay. So what I'm going to do is just to let you do some stupid copy paste. Okay. Which is first, I'm going to add a new rounds, new rounds, which is the update of the current rounds, which is the storage dot round, okay, with the new round, which is the round which has been given by parameter, which is round, and we modify the storage dot rounds. Okay, this is the new rounds, and then after you have to create the new storage reflecting the modification, the update of the rounds. This is done easily thanks to the dot construction. You say, okay, I have my storage, and right now my rounds are the new one which has been updated thanks to the map update function which has been called here. Sorry. So which is the rounds. Or I can call it new rounds in order to to be much more explicit. Okay, and that's all. It's finished. Okay, and I can give you execution. What the heck? I'm something. Else if, sorry, of course. Sorry, I don't execute the test. Okay, so here we finish. We have built all the values, the storage, and all the functionalities we would like to implement in order to reflect the game. So here we have the storage. What we have to do right now is to write the contract itself. So we're going to the main function, and here we have to write two actions. First, we have the type parameter. So if you remember here we have two actions, which is I would like to play or I would like to conclude. And here, this one is reflected by a new variant type, which is at the upper level. And this is the parameter we are going to send to the contract. If you remind the figure where you have the behavior, the parameter, the storage, and so on, here we are defining the parameter which has been sent by the sender to the contract in order to execute the transaction, okay? So here we have the parameter, we have the parameter type, we have the storage with the storage type T, and we're going to send back a list of operation and a new storage. So here, if we keep in mind the little schema about the contract anatomy, here we retrieve everything I already mentioned before. So here the parameter should be play with a given action and conclude. Okay. So here the first one, we are going to, for each one, we are going to have a given behavior. The first one should reflect the play action, and the second one should reflect the conclude action. Okay, so the play action should modify the storage, and the conclude should also reflect a new storage. So what I'm going to do is just to remove this one. It's useless. And the action, the list of operation, we are not going to execute new operation. So it should always be the empty one. Okay. So what we are going to do first, we are going just to start by the play action. So I give you first some entries and facilities. I have the player here, the player address. So I'm waiting for the storage, the player address, and the action. And I would like to perform this action thanks to the storage and the player address, which is current. So I give you for free the first values, which is the round. So I'm going to ask the storage to retrieve the current round. If the current round it's none, I'm going to say to raise an error, which is invalid round. Okay. And optional get exception here is just a function utils, which is here. Let's just show you. If you have something which is the none, I fail with the message. Otherwise, I retrieve the value. Okay, it's just a function projection which raises the message which has been passed as a parameter here. I don't use the optional unopt because it's you cannot specify the message you want to raise. I would like to specify the message to raise in order to check it in my test. Oops, sorry. So back to the main. Thanks to this value, we have the round value. And then after, we also have the get player, we have the storage, the play address. And once again, if the return value is a noun, I would like to raise a message which user not allowed to play. At the end, here, you have a round, you have a player, and then after, you have to implement the whole action, which reflect the play action. So you have to remind that the play should be done only if you are in a waiting stage. Otherwise, you have to fail. Okay, you have to abort the code. So I'm going to write it here right now, just to explain you how to do it. So if, for example, my round value, so I have the round value, is waiting. Okay, and here I'm going to from the round, which is here, I'm going to retrieve the round value related to the player. So I'm going to get the round value. Round value from the round which has been retrieved here, and the player which has been retrieved here. So here we have a playing address, we have an address, and thanks to address, we have the player, which would be player 1, player 2. So here I'm going to do player. So if this player is in waiting, it can play, okay. Otherwise, we are going to fail with, so we can do a return, fail with, and the message is came from the errors, and so we can go through errors and see which message we are going to send. User is not allowed to play, so we're going to use this message. Sorry. So the main is here. So we're going to send this message. Now, a copy. Okay, user not allowed to play. And here we are going to say, I'm going to modify the storage. I'm playing the game. So I'm going to say, okay. This one is important because I know that we wrote the code which is not going to modify it, but we are not able to say the game has been, the play has been done or not. Here the error reflects that the game could not be done. Okay, it's an error. It's not a nominal case. It's an error. This is why we have a fail with. So here, what we are going to do is just to return, and we are going to create new storage. We are going to update the storage. So we are going to storage. We're going to call the update. Okay, and we are going to update the round of the storage. So the current storage is given by the value storage here. And what we are going to do is just to act on the round, calling the play function for the given one, which is the current one, with the player which has been identified just before, which is the one which has been synthesized here, computed here, and the action which should be done is the action here. And that's all. Okay, so here we reflect that the nominal case is if the current player is in the waiting state, then I can play. Otherwise, I'm not allowed to play. I cannot play. Okay. If you see here, we can change the message because here we have user not allowed to play because it's not the right user, and I use the same error for the player which is not able to play. Maybe we can add a new message in order to be much more precise. And the conclude is quite easy. I just let you. I'm going to write it because we have to deal with. First, in order to conclude, we have to retrieve the current round and check if both players has already played. So this can be done easily. We can retrieve just the current round here. Then after, I would like to retrieve, and I'm going to use the same, in fact, the same construction as this one. Okay, but with the player 1 and the player 2. So I'm just going to say if the player 1, the run value is in the play state for the run and the player 1. Sorry. It's okay. And the run value is in the play state for the player 2. Both players are played. So, sorry. I can conclude saying I can conclude and saying I can create a new storage, a new game, sorry. So return storage dot new game of the storage. Okay, so I initiate a new game. This one is finished. I initiate. So I don't say who win and so on. This is not the topic. Otherwise, I should return an error right now. So once again, I can say I return the same storage and that's all. Or I can say something which is much more stronger, which is, okay, I fail with, but an error which states, okay, I cannot conclude. Okay, this is just to mimic and to explain that once we have this cross here, it's forbidden, it's prohibited. Otherwise, if I return the storage as is, the play has been, the conclude has been performed, but it do nothing. Okay, so here I prefer to send an error which states, okay, I decide to raise an error. Finally, we wrote the play I conclude. So maybe we cannot start to play with the contract, because if, for example, if I decide to execute the contract, we will have some issue, I guess, because here, as you see, rejected action. Okay, he said that he cannot execute the code because the main entry should be written. So here we have to deal with the main action. So we have to deal with a variant type. So we have to call each entry, each behavior related to the parameter which has been received. So we know how to do it. This is done thanks to a match function for the given parameter, sorry. And we have to filter both play with the action and conclude with no parameter. So here we have to just call directly both behaviors. So when we have a play, we can call it immediately. So now what we are going to see is the usage of the Tezos library. So we have to go through the API and browse Tezos, the Tezos API. So here in the Tezos API, you have different capabilities. Here, as you can see, you can, for example, calling Tezos.balance, you can retrieve the balance of the contract once you're executing the code. You can retrieve the timestamp, the current time, which is provided by the VM. You can compare, of course, the timestamp. You can have the number of days which has been set up when you execute the transaction. Okay, if you remember, you have the third parameter in the contract, which is the number of days you decide to give once you execute your transaction. So here, this one lets you retrieve this value. You can retrieve the sender. So who send the data in order to perform the transaction? So this one is also explained here. If you remember the Shifumi, the test here with the source, set source or set sender, I don't remember because it's related to the test. Back to the Tezos LIGO library, you can retrieve the address of a given contract and so on and so on. You can retrieve your self address. So you have different approach, and you have also the get the originator address of the current transaction. So who sent the transaction? Okay. And if I remember something, I would like to retrieve the. Okay, you have this, and the one which I'm going to use is the sender. Get the address not that initiate the current transaction. So we are going to retrieve the Tezos sender. I don't remember the get the originator address of the that is if a chain attracting to the current which gives the address of the contract or user which directly calls the current transaction. So we have two capabilities to use to retrieve an address, which is the source and the sender. But this one is related to the Tezos. We are going to use the sender. So here, if we want to implement right now our main function, you just have to deal with first, we have to retrieve and to send back the list of operation We have no list of operations, so we can say I send back a list of empty, which is empty. Okay. As list of operation, I have to mention the type because it's not able to type check since my list is empty. So it's not able to infer the type of the parameter type of the list. So I have to help the compiler giving the type, and then we can call the play function. The play function with the storage, which has been retrieved here as an entry point. Okay. Sorry. And the Tezos sender. So who initiate this this transaction, and the action which has been sent, which is the action here, which is capture thanks to the variable A here because of the matching, and A. Same for the conclude. We're going to call directly the conclude with the storage. Okay, that's all. And as if you remember, I say we don't care who called the conclude. I don't care. The most important part is the Tezos senders. I care who is calling the action, so I have to retrieve it. And it's the Tezos sender give us the address, and then after we are able to retrieve the right player for the address, which would be maybe a player which is not allowed to play. And that's all. It's finished. So here we have a complete contract which reflects all the gameplay for the Shifumi. So I'm going to execute. I hope it works. Okay, everything works fine. Okay. Okay, so we finished the contract, and we have all the tests which are being covered thanks to the integration test I explained at the beginning, and which cover also the documentation which is set up in the README. Anyway, we have a problem with this contract. Do you know which problem we have? Tezos link, sorry, yeah. Sorry, I just see the message for Sunbachu who asked me to send the GitHub link. So I resend it. So did you see the problem? Did you have any expectation? Did you see if there was a problem or not here in this game? I let you. I give you 2 minutes to find to tell me if you have a problem or not. You have to remind what a blockchain is and what properties are attached to a blockchain. Because here we write a contract, but we don't the fact that it's run in the blockchains, it's just related to the fact we are managing addresses and so on. Okay, we agree with this, but we don't keep in mind and we don't carefully keep in mind that what a blockchain is. This game is not a good game. The implementation is not the good one. So if everybody see why, we can write or try to write something, and we can have a short discussion. But this game is not a fair game. So I can give you the response. It's not a fair game because once I execute the test, there's something which has been done here, which is the test which is called why this solution is not a good one. And we can go through this test. It's not really a test. It's a test we do the complete origination, but the most important part is this one, okay? It says that Alice is going to play Alice play with the material which is paper, send 10 tests. And then after in my test, what can I do is I can retrieve the storage and log it, okay? So if I'm Bob, I can say like for example, Alice says, "Okay, I play. I'm waiting for Bob to play." Bob could do something. He can use the standard tools provided by Tezos, which let us explore the storage, and he can see that Alice has played, and of course that Alice played, and she played paper. Oh, so let's play Sizo, and I win. So this game is not a fair game because everything can be seen and can be seen in the blockchain. The storage is not hidden. You can see the storage during its lifetime every day, at every moment. So you can decide to observe it. So in this case, since this game is based on turn and on two players which are playing, once the first are played, the second one can see the result and can play in order to win. So this is not a fair game. So this is one important thing. As we can observe the storage every time, implementing a game where something should be done and should not be observable, we should use something different. And this something different, this is a feature which has been provided by Tezos, if I remember, in the protocol, which is Hangzhou. Yeah, which is the chest. And the chest give you the opportunity to cipher some data, store the data which has been ciphered, and then after you can reveal opening, for example, your chest and deciphering the data, or providing the material to decipher the data and reveal the action which has been played before. Okay, so for this purpose, the game should be reviewed, and we have to review the game in order to provide a game which is done not only on one action, but multiple action. In the first version, we have an action which is play and conclude. Right now, we have to do something which is different, and we are going through, which is version 2. And in version 2, we are going just to browse. Version 2, and I'm going just to go on the entry version 2 here. Okay, and here we are going to define new operation, and here we are going to prepare an action, okay, which should be stone, paper, and Sizo plus a secret, sorry. This one should be used by something which should be a chest. So we are going to send the action which has been ciphered thanks to all the material to the smart contract. So if you try to observe the storage right now at this moment, you see something which has been ciphered. So you are not able to know if the action has been Sizo, paper, or stone. So the game is no more unfair, but it's a fair game right now. So then after the other player can also send the chest action, an action which has been chest, so ciphered. And then after, when both player has played, we can decide to reveal the action, sending the material which has been used off-chain in order to cipher the data. You send this information on-chain to the smart contract in order to decipher the action, and then each player has to send this own material in order to decipher and to open the chest. And then after, once each player has done the chest and the reveal, we can conclude the game. But here we have to deal with the capability and the property that every storage is observable. So if you want to deal with information which is important, not how to say, a kind of public during a given for a given duration, you have to use this chest capability, which is provided by Tezos in Hangzhou, protocol Hangzhou. Okay, and of course you have new additional properties, additional prohibited sequences. You cannot call chest and reveal, otherwise it's unfair once again. You cannot chest and reveal twice. It's stupid. Okay, it means that the first prohibited schema still the same. You cannot play twice, of course. You cannot reveal once nobody plays and so on. Here we are just introducing prohibited sequences with the reveal action. You cannot chest, reveal, and call the conclude. You should wait for the player 2 to reveal, and so on and so on. Okay. So right now we are going to go through the version 2, and we're going to see what kind of data should be managed and modified. So here, what I'm going to do is just, we are no more doing live coding. I'm just explaining step by step things to be done in order to just introduce you the concept step by step. So first, the action, still the same. Well, still have the stone, the paper, and the sizer. Nothing changed. Okay, that's fine. The round value. The round value, as you see, we have the played, waiting, played, and what we would like to reflect, we would like to reflect a third state, which is I'm waiting for the player 1 to play. Then after the player 1 I played, but he should not play an action directly, but he should play something which has been chessed, okay? Something which has been ciphered. So this one should be changed. This one should be changed thanks to the data type which has been provided by Tezos, the Tezos library. So this one. So here we have a type with a type for chest. Okay. So we have two types: the chest key and the chest. The chest is the data which has been ciphered, and the chest key is the key to open and to decipher the data given a secret. For example, you can open a chest with the chest key, the chest, and the natural, which is the secret, And then after we have a chest opening result, which is of course a variant type. The chest opening result can be OK opening with the bytes, the information which has been chased. You can have a failure once you try to decipher on the decryption, or we have a fail with a time lock. You can have time lock and time lock on the chest. You can decide to say that the chest should not be deciphered for a given duration. Okay. So you can give a time lock and say, okay, this one could not be opened during, for example, 10 minutes, 20 minutes, 1 hour, 2 hours. Okay. In order to create a chest, you have a function which is create chest. You have the bytes. Okay. You have your secret, and then after you have two results. You have a pair, which is the chest itself and the chest key. You can, of course, create a chest key thanks to the chest and the natural, the secret. So it means that if you have the chest and the secret, you can recreate the chest key, and so on and so on. Okay, and this is the basic API used for the chest provided by Tezos. So here, if we go back to the version 2, we have to deal with two new states, which is what I'm going to play is first a chest. Okay, as mentioned, we have something which has been ciphered, and then after we have a third state, which is it has been revealed, and the reveal operation gives us the action which has been effectively played by the player. Okay. Of course, we have to deal with by the waiting and so on. So we have to increase the number of cases because we add a new one in to the variant type. So we have to deal with the reveal. Here also we have to deal to the reveal, and we have also to create a new predicate which mimics the fact that the action is revealed or not. So this one, okay. Oh, this one has been okay. I have the code. And then after, we have to deal with the play function as usual, or the reveal. And if you remind for the version 1, the play has been done just doing the matching, filtering, waiting, and play, here we have to filter waiting, play, and revealed. And if we remember, if we would like to play once the played is already the current status, we do nothing. So we should apply the same approach for the revealed value. So the play should be done simply with this one, just replacing this one by this code, which states the fact that if we are waiting state, the next state is play with the action. Otherwise, if it's already played, we're still in played. If it's revealed, we stay in revealed. Okay. And then after here, so here the decode is a function. I propose a function with a chest and which will retrieve an action in order to hide all the complexity. So here the reveal can be simply implemented, returning a match of the round value. Okay. So if it's a waiting, if we are in a waiting status, sorry, we still stay in the waiting state. Sorry, it's 0. So we still stay in the waiting status, of course. If we are in played P, played, and we would like to reveal, so therefore we can say, okay, we are in the play status, we would like to reveal, okay, so we can return a revealed operation and use the decode function in order to retrieve the chest, the reduction from the chest, and the chest is here. So I'm going chest here, so we can call reveal with decode of chest. I can explain you why I use this function, because the chest, the functionality of chest and so on cannot be used on the integration test. If you try to do it in unit test, you cannot. So you have just to create fake function in order to produce it, and you have to mock it, you have to provide a mock. So the decode can be implementing with the real code or just implementing using a mock function in order to mimic the mechanism. And this should be done, for example, in unit test. And if it's been already revealed, so here I don't have to, yeah, sorry. The revealed, I just have to say, okay, I still in revealed status. And that's all, finish. Okay, so here we just have to increase. So if you remember when I'm talking about adding new player, here we have to add a new entry, new value, new constructor in your in our sum type, in your type, which is T, which reflects in fact the status of a player. And then after we have to review each match. And this is done thanks to this should be done thanks to the exhaustiveness, which is checked once your compilation. So you cannot forget a case once you review the code. Okay. So maybe we can try to do some tests. Oh, I'm still in version 1, sorry. Round value. I forget something, I guess. Which one? Where? 47. Ah, reveal of P, of course. The action. I call it action in order to have. Okay. Test round. Okay. So the round value has been revisited. So right now we have to review the round. And if you remember, the round manipulates round value and so on, nothing else. So the round is here. And it says only one thing in the play here. You cannot use the action T once you play the action. You have first, when you play, you have to send a chest. So this is first the first thing you have to do is just to improve and to see that you have to modify the signature of the play, because right now we don't send directly the action, but we send the action which has been ciphered thanks to the chest action. So we can try to okay. And right now we have to, of course, since we have to review the play function, we have to define the reveal action. So what I'm going to do, I'm going just to introduce the reveal here with the same signature, except that we are going to reveal for the given player and the given round. I would like to reveal the action with my famous function, which can be mocked or not if we want to execute on the test or not. Okay. And then after, we have once again something to do, which is, okay, if I'm the player one, I would like to do a reveal view, round value reveal, the round 0, but not with the action, but with the decode function. Otherwise, it's a player 2, I have to send the rounds at the index 0 as is, and I have to call the reveal action here with the decode. And let's conclude. Let's conclude the review, the code review for the round value, and nothing else. The storage is not meant to be modified, okay? Because we have nothing which is related to the fact we are going to play. It's just the update of the storage. So this is why you're going directly to the test file Shifumi, and here you say, okay, you are waiting for a chest, but I have T, which is, if I go to the main value, you say, okay, now play. I have to deal with a chest and not an action. Okay, so let's do it. I change this with a chest. Fine. And let's change it also with the play action here. What I'm going to play is the chest. Okay, let's try to continue to compile it. Okay, I have some tests, and here, if you remember, I have 3 actions, which is play, reveal, or conclude. So right now, I have to say how to reveal. I have to define the fact that I reveal. So if we go back to the Hangzhou library, in order to reveal it, the chest, we already have the chest. What is missing is the chest key and the secret. So what we can do is just to send, once we want to reveal, we can provide the chest key, which is mandatory, and the NAT, okay? Of course, since we have the reveal here, we have also to implement the reveal in the match. And of course, we have to implement the reveal. So just what I'm going to do is just to copy this one. I'm going just to call reveal. And with the sender. So here, P is a tuple, so we have to send the tuple, or we can perform deconstruction. So I'm going to perform deconstruction. And I'm going to define my function reveal here right now. I'm calling reveal. So if you see, we just enrich and modify step by step the code in order to have, in fact, the chest key, the new entry, in order to have, in fact, a fair game at the end. And we also have the secret, which is my natural. Okay, and now I'm going to do fail with to do. Obviously, I think here we have everything which has been done incorrectly and which mimic the fact that we can play, reveal, or conclude. Oh, if we a space, we have a coloration for the constructor. Okay. So user not allowed to reveal, not found. Okay. So here, if we go through the test, because if you do some TDD, you write the test and so on. So here I write the test from the beginning. Okay. So here it says that once I would like, once I call the contract with play and I try to reveal, I'm not able to reveal. If you remember the schema, which is this one, I cannot chest and reveal. So I cannot play the chest for the chest value and I cannot reveal. So we have to first, right now, we have to implement the reveal, the reveal action, which is here. So we are going to retrieve the round of the player once again. That's easy. And here, now, I can, the reveal, the reveal function can be done only when both players have already played. Okay, so if both players are in waiting stage, we should fail. Otherwise, if both players have played, we are in played or not status. Okay, so we can try to reveal. So first one is if player 1 and player 2 are in waiting states. Okay. We cannot reveal at all. It's impossible. Okay. So here we should throw an error which says, okay, we return a fail with an errors. I don't remember errors. And errors is user not allowed to reveal. Okay, fine. I don't know why was such a. Okay, so this covers that the reveal cannot be done once, for example, here, we cannot do the reveal here because the second player has not played. So this reveal should be rejected. This is the role of this guard. So if the player 1 is waiting, and the player 2, not and but or, if one of the player is in the waiting stage, we have to reject the reveal. Otherwise, we already have an unfair game. This is what we don't want. This is what we don't want to do. And if the current player, so this one, I'm sorry, I do a lot of copy paste, which is really, really nasty. If the round value, the current player is, we know that is in played status, we can reveal. We are able to reveal it right now. Otherwise, we cannot conclude. In each case, we cannot conclude because the player is not in a played status, so is not maybe waiting on. So we cannot conclude. So here we can write the code directly. Return fail with errors with cannot conclude. Okay, and then after here we have to write the nominal case. Both players have played, so they are maybe in played and or revealed. The current player is in played status. Okay, so we can reveal. We are able to reveal. Otherwise, we cannot. So we just have to return a storage, which is updated, where we update the round. Then just calling the same kind of feature, but instead of calling play, we're going to call reveal here, the round, the player, but we are not going to send the action, the chest action directly, but we are going to send something, which do the chess decoder. This is the most difficult part. Here, what we're going to send is just a function which is a chess decoder. So for the facility, I already create the fact which is the function which is the chess decoder. Donc here, this part you can go through this part later, but trust me, this one create the function which is we are waiting for. Okay, this create the right material, do the decode chess and so on. I'm not going through this code because you have to see how to do the serialization, and how to perform the chest and the decoding of the chest. Okay, so I'll let you go through this code later if you want, but just for the implementation here, what we're going to send here is just to send instead of the action. What we're going to send is the chest decoder, and yes, the chest decoder, sorry, with the chest key. And this one is provided by the small library which has been given, secret. And of course, this one we have to give the type because it's not able to synthesize it. Okay, and that's all. So this part is maybe the most difficult one, which is the calling the decoder. I do it in order to have tests which can be done in unit test and integration test. If you do only the integration test, you don't need this kind of facility and this kind of artifact in order to hide the complexity, and also in order to permit and to let you write test and unit test and integration test using the chest capability. And that's all. So here, as you can see, we have to think about we have to really think about the property which are linked to the blockchain, which is storage can be we can observe a storage every time. So based on this property, we should design the code. If you want such property, which is we would like to implement a kind of challenge between different senders, and this challenge should be fair. You have to keep in mind that you cannot do directly. You have to use some specific tools and some specific data types which are provided by the blockchain, like the chest, in order to let you write code which propose this property, which is I can deal with the value only when every people have played or have given its own, for example, signatures and so on. So if you need something like this, you need to design something which is done in different steps, not in one step, but in two steps, for example, which is I would like to perform something, and then after I would like to reveal what should have been done. For example, if you want to perform, I don't know, a game when people have to send money in order to, for example, to buy something. Then after, you know that people are going to offer a price, but if you want to be fair, you have to hide this price. And then after, once every people propose the price in order to pay something, you have to reveal it. So you have to think about this mechanism, and this is the main focus on this workshop. Is we can do things quite natural, but we have to keep in mind that we are working on a blockchain, and the blockchain has properties. So we cannot do anything. We have to think about the fact things should be protected during a while or once people decide to open it. Okay, so this is writing a smart contract is not only writing code, but it's also writing code in coherence with the blockchain which is behind and the whole system. So this is what. So if you go through the Tezos proposition, for example, for FA2 and so on, you have something which is which mention the rules and explain what should be things which should be done and so on and so on. And this is the purpose of the specification, explaining you what is mandatory and why this information and why the implementation which I require are important. Okay. For me, it's this finished the session. I hope it helps you. I'm sorry for the end because I have to go really to go fast, but I really need a long time to a lot of time in order to see how we can create a whole contract using all the capabilities of GSLIGO, the capability to order, to create different files in order to have modules, in order to have, how to say, a well-structured program contract, how to build a contract, what is a contract, and then after to show the trap you can have since you are dealing with the blockchain, and how to deal and how to how to deal with the mechanism, the properties linked to the blockchain, thanks to the data types which are offered by Tezos, for example. Okay, so this is what I would like to say. If you have any question, do not hesitate. We spent 3 hours. I'm a little bit exhausted right now because it's not so easy. And once again, sorry for being so fast at the end. But here you have the GitHub project you can play with. And once again, if you have some question, do not hesitate to ask questions directly, mentioning, for example, if you have some issue, you can post an issue. If you want to talk about the smart contract, the workshop, for example, via Discord and so on, do not hesitate to mention it. So which is, I would like to play with the workshop, but I have the problem. I don't understand this part. Please, can you explain me? And it was a pleasure for us to explain to give back our knowledge related to GSLIGO and the framework, the testing framework, and capability to deal with Tezos functionalities. That's fine. It's finished for me. So I'm going to just
Hi, Didier. Are you done?
Yeah, done.
Okay, awesome. Thank you so much. I think everybody is also sorted through, and there is no questions as I see. Didier, before you leave, I would like you to share your Twitter so that people who have joined in can reach out to you for any assistance and follow you. Please put that in the chat box so that people can actually follow you, and like if there's anything they might probably would want to reach out to you. And thank you so much, everyone. And thank you so much, Didier, for taking your time out and doing this on a Saturday. I know it is difficult for all of us to join on a Saturday, but I'm sure the entire community learned a lot. Thank you so much once again. Thanks to all of you who joined. I really hope, I really hope all of you will check out the recordings on YouTube channel. It'll be there on the Tezos India YouTube channel. So you can check all the recordings over there, and I'd like to say thank you and a happy weekend, and thank you so much, Didier.
Thank you so much also for you. Thank you so much. Thank you for being patient with me.
That's absolutely fine.